Ladies and gentlemen, boys and girls, children of all ages, today we are going to do our thinking problem. Our thinking problem involves many steps. Allow me first to read the problem to you. The problem is as follows. A bakery ordered 123 crates of eggs. Each crate contains 36 eggs. Estimate to find out about how many eggs the bakery ordered. So first you're going to estimate to find out about how many eggs it ordered. So that's the first thing you do. You don't estimate once you find your answer. You estimate first. Then find the exact number of eggs the bakery ordered. So that's the second thing you have to do, is find the exact number of eggs that the bakery ordered. And third, you have to explain in words how you know your answer is reasonable. You're explaining in words how you know your answer is reasonable. All right, so as I solve it, if you have something different in your explanation, with your estimate, or with your actual solving, then please correct what you have. All right, so first I'm going to write down or circle what's important. You have this problem in your journal. So I'm going to write down some stuff that's important for you to have circled. If you don't have it circled, you'll circle it as I write it down. The first thing I need to know there are 123 crates of eggs. So if you don't have that underlined, circled, highlighted on that question, do so now. The second thing, I know each crate has 36 eggs. Then I'm going to identify what it's asking me to do. 1, I need to estimate. 2, I need to answer. And 3, I need to explain. If your answer in your journal right now doesn't have those 3 things, you're going to want to fix it as we go through. You have to estimate your solution. You have to give an actual answer to your solution. And you have to explain your solution. First, let me ask you a question. We want to know how many eggs. So we're estimating eggs, answering eggs, and we need to know how many eggs. So, Taylor, can you have a decimal point in your answer?
Yes and no.
Yes and no. Okay? Depends what your answer is. If you have numbers behind your decimal point, what's that signify? Yes, ma'am.
That it's not a whole number.
That it's not a whole egg. Is the bakery going to order part of an egg?
No.
No. Does your number have a decimal point? Yes, because every number has a decimal point. So Taylor's right when she said yes and no. Yes, the number has a decimal point, even if it's not written. No, it's not going to have any numbers behind it, because that would signify a part of an egg. We don't do parts of eggs. All right, so first we're going to estimate. Estimation is done before you solve the problem, not after you solve the problem. Before you solve the problem. So about is a key word for you to look for. I know we had an assignment last week that said about how many. And somebody figured it out and said that answer is not there because they didn't look at about. Evan, so what did you do to estimate this?
123
Okay?
And 36 becomes 40.
And then what'd you do with those two numbers?
And I multiply.
Good. 123 becomes 120. That's close. 36 became 40. Because that's close. Now, let me show you a little multiplication trick that's going to save your life one day. When somebody breaks into your convenience store that you own making millions, and they say, what's a multiplication trick if a number ends in 0? The trick is what, Evan?
You take out the zeros and you add the numbers that aren't 0. You multiply those.
Good.
And then you add the zeros at the end.
Good. I'm going to take, if I have a 0 at the end of a number, okay, because 120 times 40, it seems like it's going to be a lot of work. And an estimate shouldn't be a lot of work. So if I have zeros at the end, I can just put those 2 zeros down. Then I'm done with those. And because I know my multiplication facts, then I'm just multiplying 12 times 4. So it's 12 times 4.
48.
48. So our estimate is 4,800. Which means when we get our actual answer, it should be somewhere near 4,800. As I was walking around, I saw answers that were not anywhere near 4,800. Fred.
Can I do the problem?
Okay, tell me what to do.
Okay. First, you put it 123 times 36.
Okay, 123 times 36. Where do I start?
The 3 times 6.
Okay, I'm going to start in my ones place. I'm going to start in my ones place. So I start, Fred, 3 times 6 is?
18.
18. I put my ones place down, and I carry my tens place. My next number is going in my tens place. So I'm actually multiplying in this 6 times 20. So what is 6 times 2, Fred?
6 times 2 is 12.
Plus 1 is?
13.
13. I put that in my tens place. I carry my 1. Fred, 3 times 1 is?
3.
Plus 1 is?
4.
4. So when I've multiplied my 6 through my top number, my top factor, yes.
You did the 3 times 1.
Oh, 6, so that should be 7. Thank you. Okay, when I multiplied my ones place of 6 times 123, I got an answer of 738. Okay? I am done. Yes, sir.
I used a trick. It's called
The lattice method? Yeah, I'm going to show you that later in the week. Okay? So now I'm done with my 6. I am done with my ones place. And since I'm going to start multiplying in my tens place, my first number that I multiply needs to be in my tens place. So I have to put a 0 there as a placeholder so that now I'm going to multiply from my tens place. I'm done with my ones place. I'm done with what I carried. And I start now with my tens place. So Jocelyn, 3 times 3 is? 9. And what the actual problem is 30 times 3. That's where I got my 90. Okay? 3 times 2, Jocelyn, is? 6. And 3 times 1 is what, Jocelyn? 3. Make sure when you're doing this, you line up the place values. If you need graph paper, I can provide some graph paper. Okay, so if you need graph paper, when you're adding, subtracting, multiplying, or dividing, that'll help you greatly. Okay, now we add. We have our ones place right above our ones place. So class, what is 8 plus 0? 8. We have our tens place directly above our tens place. Class, what is 9 plus 3? 12. I put my 12 down, my 2, carry my 1. Okay? Class, 7 plus 6 plus 1? 14. I carry my 1. 3 plus 1? 4. Okay? So, 4,428 is what I'm saying, and what we're saying is the exact number of eggs. So we're saying this is our estimate. This is our exact answer. for the number of eggs. Did I do anything wrong, Alexander?
No, I just wanted to say that I did it by hundreds. Like, instead of doing 120, rounding by the tens, I rounded by the hundreds.
Okay, so 100 times 40,
So it's basically 4,000.
4,000. Okay, your estimate may not be the same for everyone, depending on how you take your numbers and round them before you're multiplying. But your estimate and your exact answer should be somewhere near each other. We rounded down on our number of cartons and we rounded up on our number of eggs. So I'm not going to get exactly to 4,800. Dominic.
Like what I did 100 times 40 when because I was rounding to my tens place because that's all I had was my 40. And I got 4,000.
4,000.
I got the same answer as you, and then I rounded down to 4,000.
Okay.
That was my estimate.
But your estimate needs to come first.
I know.
Your estimate needs to come first. Okay? So everybody's cool with me so far? How I got the estimate, how I got the exact answer. Yes?
Yes.
All right. Now, I'm going to call on a few of you and ask you to explain loud enough for us to hear. Loud enough for us to hear how you know your answer's reasonable. How you know your answer's reasonable. So, let's start with Ashley. Do you want to explain what you wrote? No? Okay. All right, who wants to explain what they wrote? All right. Lainey.
I know my answers. I multiplied it, and then I went back and
Okay, so she multiplied it, then she went back and checked it. How did you check it?
I did the multiplication.
Okay, so she did the multiplication again. Okay, that's one way to check. Make sure you did your exact answer. Alexander.
The way I checked it was basically how I knew my eggs were eatable. I knew the number of crates of eggs. I knew how many eggs were in each crate. So I rounded those two numbers to the hundreds and the tens. Got 140 times those two numbers because I know that's how you can find the number of eggs total. So when I did that, I got 4,000, and then to check it, I did the actual solve the problem.
Okay, cool.
And if you do it in division, you should get the same answer.
Good, excellent. Division's an inverse operation of multiplication. So another way I could check this is I could take my product, which is my actual answer to a multiplication problem, my product, and that would become my dividend. And I would divide it by, my divisor would be 36. And if I did my multiplication correctly, my answer should be my other factor of 123. I'm not going to work this out right now, but your answer should be that factor of 123. Does that make sense? Another way, another thing you need to look at, you can't just check your math. You need to go back to the problem and reread the problem. Bakery ordered 123 crates of eggs. Each crate contains 36 eggs. We want to know how many exact eggs. Okay? If we got a number like 5 billion, would a bakery order 5 billion eggs?
I would hope not.
No. Is 4,428 sound like a reasonable number of eggs a bakery would buy?
Yes.
Yes. Okay? So, you need to not only check that your math is correct, but also that it makes your answer make sense. Okay? Because people know, including myself, when I write a question, I know what types of mistakes that fifth graders are going to make. And since I know that, if it were a multiple choice question, I would put the answer down. Okay? And if you didn't read the problem and check that it was reasonable, maybe I would divide 36 into 123. And if you did that and you got an answer of, I'm just guessing, 3 remainder 4, or 4 remainder whatever, that answer would be part of one of the 4 answer choices. And you could say, hey, I did my math correct, but you didn't go back and see if the answer made sense to the question that was being asked. Claro que sí?
Yes.
Yes.
All right. Boom shakalaka, love you all. Be blessed day.